today we will discuss about the critical path and total float, how to calculate all those. Generally in exam, what you will get it will be like a paragraph of statement, and then your activities will be given like say for A can start at a very fast day, and B also can start on a very first day, but C is dependent on A and B. So if you see this particular area, I just started as a chart. You may not get exactly the same chart format, but you might need to convert the chart format from the text that will be given in the exam. So if I say that C is dependent on A and B to complete, then this A and B must be completed, and you just add that C is dependent on A and B. Again, similarly, if say that D can only start after completion of A, then you need to add D as activity, and A is preceding activity. So it is actually preceding activity of the current activity. Now, let's talk about this diagramming method, this network diagram here. So from this, when you make this particular chart ready, then it is much easier to draw a kind of chart here. And what you will do is you will create your start activity and end activity. Now, looking at this particular table, you can just plot that A can start at the very first day. So start is the preceding activity. It is not activity, but start is the preceding activity of A. And also similarly, B can start on the same time the A started, so B also can start on the day one. So if it is can start on day one, and if I say the duration is 4, then how much time it will be? So it will be 1 plus 4 minus 1, because the minus 1 is because you are actually working on day 1, so you are counting day 1 as your in your count. So the final day must be 1, 2, 3, and 4 is the 4th day. So it will be 4. So the formula for this will be your total durations plus your starting day minus 1. So I get that in A started at day 1, it is continued for 4 days, and then it completed on day 4. Now B also, if I see in start, B can start on the day 1, and it can continue for 5 days, so it will be finished on the day 5. Now I say that C is dependent on A and B. So C here is dependent on A and B. So C can only start when A and B both are complete. So both will be completed on you should take the highest day, because B is taking the highest day here. So C cannot start before day 6. So C's start activity will be day 6. Even though A is completed on day 4, you need to wait for one more day here so that B can be completed. So day 6, C will start, and it takes 7 days to complete. So finally, we will get 6 plus 7 minus 1 is 12. Day number 12, C will be completed. Now let's come to activity D. The activity D can start after A is completed, so it does not need to wait for B or C anything. So it can start just after the A is completed. So it's day 4 A completed, so day 5 we can start the activity D. Now D takes 3 days, so it will be 5 plus 3 minus 1 is 7. So day 7 D can be completed. Now going going forward to activity E, its preceding activity is C and D. So C is completing on day 12, and D is completed on day 7. So we need to wait for C to complete. We need to wait till day 12, and the next day we can start day 13. So all this point, when one activity is waiting for the 2 other activities to complete, so that point is called the path convergence. So in the path convergence, we have need to always wait for the highest activity duration, so that we can start the next activity after everything is completed. On day 13, if we start on activity E and it takes 6 days, So the final day, it will be completed on day 18th. Now, F is depending on only C. So it does not need to on D. Anyway, it is C is the highest one. So here it will be on day 12, and the next one will be 13. The next day will be 13. So F is checking 4 days. So 13 plus 4 minus 1 will be 16. So considering all the other activities, we see that 18th is the highest date here. So the project cannot be completed before day 18th as per this current network diagram. Now, what is the critical path? Is the longest path for the shortest possible project duration. So we cannot complete the project in 17 days because based on the dependency here, E should be completed or must be completed on day 18. So that is the minimum day it will take, or the longest path here in the network diagram. Now, how to calculate the total flow? So the activity we just did was the forward pass. We need to do a backward pass now. What is backward pass? Backward pass means we just know what is the longest project duration. So we know that it is 18 days. Now we need to move back from the end to the start and see if there is any gap or any activities can be waited or delayed so that the project schedule does not get impacted. So let's start like this. So 18 days are your highest day. So you will plot like 18 here. So E must be completed by 18 days. And if it is completed in 18 days, duration is always same. So you must complete it by day 13. So the formula here will be the end date minus duration plus 1. So it will be end date minus the duration plus 1. It will be just the reverse of the forward path. So your formula will be 18 minus 6, that will be 12, plus 1 is 13. So you will just complete 13. Now one more thing is too, that if your the way to calculate the float is your forward pass duration or the day and the backward pass duration the day, the difference is called the total float. So here the total float is 0. And one more thing to remember is any activity in the critical path is 0. So while the critical path is starting from here, coming to B, then C, then E, and then finally N. This path is called the critical path because this is the path that is taking the maximum durations. So now we are here and we know that E can be completed on day 13. So here also, if we know that it can be completed on day 16, but we have luxury of waiting 2 more days here because anyway E is completing on day 18. So if is it can be completed on day 18, so that there is no change in the project schedule. Now, if it can be completed on day 18, what will be its starting activities? It is 4 days means same formula 18 minus 4 plus 1 is 15. So now you see here the total float is different. So here the float is 2. So we can delay this particular activity F by 2 days. Now if it can be completed on day 15, then which date this can be completed? This can be completed or must be completed on day 12 because this is dependent on activity E. So if we delay this activity, we will delay this E that will actually impact your project schedule. So you cannot delay this C. So it is 12 and so it will be 6 here as well. So as I said, like this also critical path, so it must be 0. Similarly, B also it will be 0 because all are dependent on the next activity and you cannot change it. Now this day D it was completing on day 17, but it was waiting till day 13 to complete the activity, to start the activity E. So we can delay this activity till day 12 so that there is no change in project schedule. And so the formula for starting of this project is the late start will be day 10. So now here the total float is 5. Now the activity A, we we are completing in day 4, but we know that it is starting at ending at day 10, and this activity C can start on day 6. So without dealing anything, we can complete it on day 5 so that there is no change on activity C or activity D. And if we do that, we can start the A on day 2 as well instead of doing in the fast phase. So here the total float will be 1. So you now understand how to calculate the total float and the critical path and what is the project duration. So I think this video will help you, and thank you. Thanks for watching.